Hi, today we're going to see a short video introduction of alvaModel 2.0. alvaModel is a software by Alvascience. To check more Alvascience solutions or for further contact, please check our site, alvascience.com. alvaModel is a software tool to create quantitative structure, activity, and property relationship models. It can be used to create both QSAR, QSPR, regression, and classification models. A regression model is trained to predict a quantitative variable, like an ecotoxicological endpoint, while a classification model deals with a qualitative variable. Of particular interest are binary classification models, where the target variable has two possible values, also called classes. alvaModel starts from two input files. The first is an AlvaDesk project, containing the molecules you want to use, and the descriptors and the fingerprints calculated on those molecules. The second input is a text file containing the target values you want to predict. The models, created in alvaModel, can then be exported in an AlvaRunner project. This project can then be applied to your molecules using AlvaRunner in order to calculate the predicted targets. This solution separates the training of the models from their deployment. Therefore, it allows you to easily deploy your models to other parties. alvaModel is available for Windows, Linux, and Mac. We start importing an AlvaDesk project. On the tree view on the left, we can see the software sections. In the Dataset section, a dataset called Master was automatically created. On the right, we can see the values of all the descriptors that are present in this project. We can now import the target values from a text file. Now we're going to split the master dataset in the training and test datasets. In this window, we can choose between two kinds of approaches. By column can be used to base the splitting on a two-values column. For example, if we already have a column identifying the molecules that are associated with the training dataset. Using by size, we can split the dataset by defining the dimension of the training dataset and the type of splitting. Two new datasets are added to the Dataset section. We can now create a model selecting manually the variables we want by using a simple step-by-step procedure. This can be particularly helpful, for example, if we want to reproduce a model described in a scientific paper. In the first step, we choose between either a regression or a classification model. In the next step, we select the type of model we want to build. Among the available options, we have a linear regression model, a KNN regression model, or a consensus regression model, which is defined as the arithmetic mean of the values predicted by other models. We choose a linear regression model. In this step, we associate the training and test datasets to be used. Here, we can select the target value among the external variables we imported. We can also select the descriptors we want to use in the model among the ones previously saved in the original AlvaDesk project. In the last step, we can choose the policy to handle the missing values and some feature reduction techniques. The model created is added in the Models section of the tree view. Here we can see a table with a summary of the model, the type of the model, the number of columns, the scores for the training, the test or all the molecules. On the right, we have a scatter plot where we can see the target values and the predicted value. And, if we want, we could switch it to show other charts, like the residuals or histograms of the variables. Underneath, we have the table containing the target, the predicted value, the residuals, and the descriptors used in the model. Both the chart and the table can be used to filter and explore the data of the model. If we want, we could add to the model an applicability domain. Or we could perform other actions, like calculating other types of scores, change the descriptors, perform a Y randomization, or perform actions specific to the type of model selected. For example, in the case of this linear regression model, we could manually change its beta coefficients. We can now try to find a model with more interesting scores by using the automatic models generation, which will start a feature selection based on genetic algorithms. Here, a similar step-by-step procedure will guide us. In the first step, we choose either regression or classification. In the next step, we can select the parameters of the feature selection. For example, we can choose the score that will be used to determine the quality of the models. The following steps are very similar to the ones we already saw. We select this time a KNN model. We can specify a K and a type of distance. We can now select the descriptors that will be used by the feature selection. In this case, we select them all. And if we want, we could select a set of descriptors that we want to be present in all the models. We leave it empty for this example, but this time we decide to standardize the data. We can see that a new node was added to the Models section. This interface is showing us how the automatic model generation is progressing. In fact, we can see the number of iterations done and the best score found so far. We can pause this procedure and check the models found. We can save the best model found so far. The model is now visible in the tree view, and we can check its data. Also, by clicking on one of the molecules, we can see details on the single prediction, like the nearest neighbors or the atomic and fragment contributions, which may help us in gaining some insight into the single prediction. At this point, we could decide to restart the feature selection procedure in order to look for other models or stop the search here. Similarly to regression models, we can use alvaModel to work with binary classification models. For example, we can create a classification model with a similar step-by-step procedure. The list of available models contains a few specific types of models. We can select again a KNN and move quickly forward with the other steps. Here, we select a set of descriptors. The AlvaDesk project we imported contains some fingerprints. Therefore, we could also choose to train our model using molecular fingerprints. We can see the classification model and check its confusion matrix and other data. Even here, we can perform action on the model, including some specific ones like, in this case, optimize K, which allows to test different numbers of neighbors for the same KNN model. When our models are ready, we can export them in an Alva runner project. We must define a project name and, if we want, a project description. The Alva Runner project is now saved, and it can be used in Alva Runner. Please check the Alva Runner introduction video for more information. To check more Alvascience solutions or for further contact, please check our site, alvascience.com.